Welcome back to our second video for Notes 23, where we're going to start off talking about the slope of linear lines. Now I want you to notice my line in our first video went down at a constant, what we call a constant rate. It was just a flat, straight line, but notice that if I was walking on it, I'd be walking downhill. Well, this has a formal name of being a slope of my hill, a slope of my line. And every linear line has what we call a constant slope. So slope can be talked about in a couple of different ways. A lot of times we use the letter M to denote it. It's like our placeholder. We can talk about slope as rise over run. This is when I am given a graph that I can use to just look at it and identify how I am changing in the Y direction compared to the X direction. Formally, slope is described as the change of your Y's, so two Y coordinates, their difference, divided by the change in your X's, so the difference into X coordinates. Notice that this implies this is where you have to have 2 points on the graph. So be sure you write this down. Slope is a number that describes the change in 2 points or 2 locations. And there are 4 different ways or 4 different types of slopes we can come up with. First, I can slope up. This will have a positive slope because I'm going uphill. The second type of slope we can see looks like this. And it's going to have some negative number that describes the steepness of that slope. That negative is going to come in anytime we're going downhill from left to right. Now there are 2 other situations. Sometimes I can have a line going straight across, or straight up and down. And these are 2 very special cases. If my slope is going straight across like this, then it has what we call 0 slope. My slope is literally the number 0. Versus if I'm going up and down like this, my slope is undefined. Essentially, my slope does not exist. Now, the way I tell everybody to remember this, pretend Miss Brazel is skiing. Now, y'all, I rode horses growing up, rodeoed my entire life. I can't ski, okay, at all. So if I'm trying to ski across a flat surface, it's going to be a lot of work. It's going to be 0 fun. It's going to be all work, no play, 0 fun. If Miss Brazel tries to ski down a vertical cliff, y'all, this isn't about fun anymore. This is my life is going to become undefined. I know that sounds kind of grotesque, but you'll remember it. If I'm having to ski down a vertical cliff like this, I will no longer be alive. That is how I remember that slope is undefined, while this slope is just 0. So let's see if we can calculate it given ordered pairs. So if you're asked to calculate the slope of a line. Remember, the slope always describes the change between 2 points. So what you need is the slope formula. My slope is equal to y2 minus y1, the difference in my y coordinates, divided by x2 minus x1, the difference in my x coordinates. So when they give you two ordered pairs like -3, 4 and -4, 2, go ahead and label them. This is x1 and y1. Remember, x always comes first with my ordered pairs. So this is the x and y from my first point. Versus x2, y2, the xy coordinates from my second point. Technically, it doesn't matter which one you put first as long as you stay consistent. So my slope would be, first starting off with my y coordinates, my second y minus my first y. So I'm going to do the number 2 minus the number 4. Second point minus first point. Always making sure to put your y coordinates on top. Then x2 minus x1. Make sure you keep it in the same order. Since we started with 2 in the y's, I need to start with its partner, the -4, when I deal with the x's. So I have -4. The formula says subtract. And then I'm subtracting a -3. Please, please, please be careful. There was a negative from my formula. There was also a negative with the coordinate. There are 2 negatives there. Make sure you have both of them because that double negative will turn me positive. So I have 2 minus 4 over -4 plus 3. This right here is why we spent so much time working on our integers towards the beginning of the semester. Be careful of your signs. 2 minus 4 is a -2 result. -4 plus 3 is a -1 result. Once I'm done simplifying, if I divide -2 divided by -1, turns into a +2. So the slope between these 2 points would be the number 2. What that is telling me is that this line will be going uphill, if I can talk correctly. Here in a minute, we're going to see what this number relates to, how it looks on the graph. Right now, all we're doing though is trying to calculate the number. Once I have the number, it'll be easier to connect it back to our graphing conversation. So skip down to number 5 real quick. Number 5, same conversation. They want me to calculate the slope. So my first point, x1, y1. My second point, x2, y2. M equals. According to the formula, first thing I'm going to do is subtract my y coordinates. So my second y minus the first one. Second y was -2. Subtract. The first y coordinate was 4. Then I move down into my x's. Starting in the same order, I have the number 1, and I'm going to subtract a -3. 1, subtract -3. There are 2 separate negatives there. Please, please be careful. Because the double negative is touching, I will turn it into a +3 on bottom. So -2 -4, since those are the same signs, it creates -6. 1 plus 3 is 4. Sometimes these fractions will not divide out nicely. You will need to leave them as a fraction, but reduce. I can divide a 2 out of top and bottom. Reducing that fraction gives me -3/2. So my slope as a number is -3/2. What that tells me is that when I go to do this on the graph, it should slope downhill. Now, the other two examples in this category are some very special cases. Then we're going to look at one in terms of a word problem, and we'll probably stop the video here or there, then creating one more video where we look at how these connect on the graph. So number 4 and number 6. Starting off the same way, they want me to calculate slope. So I take my y coordinates and subtract them. 3 minus from the formula a -2. Because I started with the 3 in this point, when I move to my x's, I need to start with its x value. So 7 minus the other 7. When I do that, the double negative touching turns positive. So I have 3 plus 2 on top, which will give me 5 on top. And on bottom, 7 minus 7 is 0. We have to remember when it is a no and when it is okay. When the 0 is on bottom, it's a big old no. What that's trying to tell me is that this slope, my m, is undefined. Because the 0 was on bottom, that's a big no-no. My slope is undefined. What that means is my line will end up running up and down that vertical cliff. For my next example, when you set it up, let's see if we can do it a little smoother this time. Y is on top, -5 minus -5, double negative. Divided by x's, 1 minus 2. Because of this double negative, I'm going to turn it positive. So I have -5 plus 5 on top, leaving me with 0. And 1 minus 2 on bottom is -1. When the 0 is on top, it is okay. It just means we need to zero out. So my slope does have a number. That number is 0. That's what happens when I have a horizontal line instead. So these are your 4 cases. Positives run uphill, negatives run downhill. Undefined is straight up and down, 0 is straight side to side. And we can even see this within real-world application problems. If a computer was worth $2,000 in the year 2019 and only $800 in 2022, find and interpret the average rate of change in the value of the computer over the 3 years. Now, average rate of change is another word for slope. Tell me the rate that my points are changing, aka the slope between my 2 points. Now, in order to do that, they had to give you 2 ordered pairs. or two situations where my variables are connecting. That's what they're doing for you right here. They're saying that in 2019, my value was 2,000. And in 2022, my value was 800. So as ordered pairs, time is our X values because those are independent. Those come first, so to speak. The values, the value of the computer, are my Y values, my Y variable, because those are dependent. Those depend on what time we're talking about. So as an ordered pair, this would be 2019, comma, 2000. Well, this one is 2022, comma, 800. And we can set this up to find my slope. Remember, the Y's go on top. So 800 minus 2,000. Let's finish setting up, then we'll figure out what that is. Because we started with the 800, on bottom I need to start with the 2022 and subtract the 2019. Now we might have to have a side conversation with ourselves. 800 minus 2,000. Because those are subtracting, I can take my 2,000, subtract the 800, 0, 0, borrow. 10 minus 8 is 2. That is a $1,200 difference. Because I subtracted the bigger number, it was a negative 1,200. On bottom, 2022 minus 2019, that is a 3-year difference. And when I divide, negative divided by positive is negative. I need to make myself some more room. Sorry, y'all. 1,200 divided by 3 is 400. Negative 400 as a slope. And what that is trying to tell me is that the computer lost, because it was negative, it lost $400 in value. That's how my Y coordinates changed. I lost $400 in value for every year that went by. So let's go ahead and stop this video here. This video is just exploring how slope comes into play when we're connecting Y values and X values. Remember that slope uses the letter M as a shortcut, and it's basically telling me how my values, how my variables have changed from the X's and Y's. Rise over run. Average rate of change all means the same thing. In our next video, last one for this lesson, we'll be connecting these slopes with our coordinate grids.